This is Algebra 2, Unit 2, Lesson 2 on function notation. So what we're going to look at is the notation that's used for functions. We did this way back in Algebra 1, but let's see if you remember how to do it and how it's described. So when you see function notation, you usually see it as y equals f of x. This is telling you something. Y is equivalent to saying f of x. Well, x is your input. That's your x value to use. When you plug it into whatever function you get, you have y. So if this is the x, this is the function rule, it gives you what y is. So when you see f of x equals 5x minus 2, they're really saying y is 5x minus 2 when you plug in certain x's. So this part right here is the y. All right, this is the x you're using to get the y. The f is the rule that you're using. So if f of x equals 5x minus 2, what do we do with the 3? Well, f of 3 is plugged in for x. 5 times 3 minus 2 is 15 minus 2, which is 13. So when x is 3 in this function, y, or f of x, is 13. So f of negative 2 would be 5 times negative 2 minus 2, which is negative 10 minus 2, which is negative 12. All right, now you can list this as a coordinate point if you wanted to. For the coordinate point for this one would be the point x is 3, y is 13. This one would be if x is negative 2, y is negative 12. So you could see f of 3 is saying when x is 3, f of 3 using the function is 13. So that works for either of these functions, any function you have. It doesn't matter with the letter. G of x is x squared plus 4. So g of 3, we plug in x equals 3. 3 squared plus 4, which is 9 plus 4, which is 13. And g of 0 would be 0 squared plus 4, which is equal to 4. Pretty simple. All you have to do is whatever's in the parentheses you plug in for x to get the function by whatever name it's given. So h of x is 2 to the x. Why don't you see if you can figure this one out, and we'll go over it in class in the next one. So h of x equals 2 to the x, figure out what h of 3 is, and what h of negative 2 is. And be very careful, see if you remember how to do a negative exponent when you're doing this one. Okay, now function rules, remember, can come in a lot of different forms. We can do it as equations like we just did. You can do it on a graph, and you can do it in a table. So let's look at a table form of this. Boiling water at 212 degrees Fahrenheit is left in a room that is at 65 degrees Fahrenheit and begins to cool. Temperature readings are taken each hour and are given in the table below. In this scenario, the temperature T is a function of the number of hours H. So let's think about this for a second. What is your input on this? The input would be, what are you plugging into the function? Well, H would be the input. That would be your X value. And T of H, or T, is a function of the number of hours, would be T of H, would be your Y value. So that is your output. So when you plug in the hours, you get a temperature. That's what's happening here. All right, so if you want to evaluate T of 2, they're saying when at 2 hours, what's the temperature? The temperature is 104. You're looking at this right here. When at 2 hours, the temperature is 104. T of 6, when it's at 6 hours, the temperature is at what time? What amount? T of 6 would be 68. Okay, how about this one? For what value of H is T of H equal to 76? All right, when you see T of H is 76, what is that telling you? T of H is the temperature. So they want to know at what when the temperature is 76, how many hours does that happen? Well, we have to go to T of H here. Here's 76. That would be H is equal to 4. So what they're saying is T of 4 is equal to 76. So when you see T of H, that's saying the temperature over a certain number of hours. And between what 2 consecutive hours will T of H equal 100? Okay, so the temperature is 100, when the temperature is 100. Okay, so find where the temperature is between 2 hours. It would be between H equals 2 and H equals 3. So between those 2 hours, you would have a temperature of 100 degrees. All right, now let's look at the graphical version of this. The function y equals f of x is defined by the graph shown below. Let's answer the questions based on the graph. F of negative 1. Let's think about this for a second. What is negative 1 in that? That is the x value. So when the x value is negative 1, what y value is it? Well, let's look at our graph. Your x value is negative 1 is right there. It hits the graph at y equals 0. So this is actually the coordinate point, negative 1, 0. So what is f of 1? F of 1, when x is 1, y is 1, 2, 3, 4. F of 1 is equal to 4. This is actually the point, 1, 4. And f of 5, when x is 5, what's y? 1, 2, 3, 4, 5. Y is 1, 2, 3, 4. There was 1. All right, so that is negative 4. So that's actually the point. X is 5, y is negative 4. So when you input into to get this function at 5, your y value is going to be negative 4. That's what you're looking at. All right, f of 0. What are they looking for there? It's when x equals 0. So f of 0, when x equals 0, what point is that? Well, when x is 0, y is going to be 3. What part of the graph is that? That is the y-intercept of the graph. So this is actually the point 0, 3. So these two are equivalent. They're saying the same thing. You just have to know what your input is, what your output is, or what your x value is and what your y value is. So the function in terms of x, f of x, when you plug in x, you get y. All right, what values of x solve the equation f of x equals 0? Okay, now this time, what are they asking you to find? They're asking you to find the x's when y is 0. So what are we actually looking for? We're looking for, when y equals 0, we're looking for the x-intercepts. Y equals 0 means we are looking for the x-intercepts of the graph. Okay, now if we were to do this graphically, what we have to look for is where it crosses the x-axis. All right, so looking at where it crosses the x-axis, it actually crosses in 3 different places. It crosses it here, and crosses it here. So what x values do we have here? It says what values of x. So x would equal negative 1. X would equal 1, 2, 3. And x would equal 1, 2, 3, 4, 5, 6, 7. So there's 3 values where x equals, and this is called the x-intercepts. These are also called the zeros of the function. Now, if we were to draw y equals 0 and intersect these graphs, that's where the 2 graphs intersect, if we cross the x-axis. So between what 2 consecutive integers does the largest solution to f of x equals 3 lie? So what are they looking for? Are they looking for x's or y's? Well, it says f of x equals 3. You're looking for the x's when y equals 3. So what you're looking for is when you have what x makes the y value 3. So the easiest way to do that is to graph y equals 3. 1, 2, 3. Right there, y equals 3. And it hits here, here, and here. This is at y equals 3. So we have x is equal to 0, x is equal to 2, and x is equal to about here between 1, 2, 3, 4, 5, 6, 7, and 8. Between 7, x equals 7, and x equals 8. So that would be the one that the largest one is between. So when you have the y value, you're looking for the x value that goes with it. All right, for the last two questions on the notes, I would like you to answer them yourself. So for exercise 4, for a function y equals g of x, it is known that g of negative 2 equals 7, which the following points must lie on the graph of g of x. See if you can answer that. Exercise 5, we're going to do together tomorrow in class. So if you finish exercise 4, exercise 5, and the one in the front of the sheet, number 1C, see if you can work them out. And we'll do those rest tomorrow.